All right, we're back for part 2.
Part 2.
You're going to notice that we are going to go backwards. Now, oh, we're not ready. Okay.
No.
Now we're just killing airtime. Just wasting airtime. Great. So you're going to notice we're going to go backwards now. They've given us what the graph looks like. We're going to write everything down and use that to write the entire function. All right, so what I gave you to start, right, this function was given to you. Now we're going to find it. All right, this is challenging. It's very difficult. You're going to make mistakes. That's okay. You're still going to learn something new. Hope so. Thanks, Natalie. All right, so first thing I do is find the x-intercepts. Pablo, could you name for me an x-intercept where the graph crosses or touches the x-axis?
3 and 0.
Very good. So I'm going to write 3, 0, and -2, 0. Those are the x-intercepts. What's the y-intercept, Tyree? What's the y-intercept? Very good. So I'm going to write 0, -2. Diana, was there a question? Great. Excellent. Now we're ready for the vertical, bless you, the vertical bless yous, the vertical asymptotes.
-1.
Why do you say -1? Well, there's one going up, and there's one going down. So we have x equals -1. What's the other one?
2.
X equals +2. Now I want you to notice something, because this is going to come in handy, and it's going to be where most of you mess up. 20-second or full? How's it 2?
Yeah.
Because this arrow and that arrow are going to get closer and closer, but never touch
So you're
this.
assuming that they're gonna keep getting closer?
Yeah,
And that's possible.
that is possible. It's happening.
Okay.
Now, do you see, Diana had a good point. Do you see how both of these arrows are going in the same direction? Or as one might say, one direction?
Yeah.
Do you see how over here, for this one, you have one going up and one going down? That's opposite directions.
Yeah.
That's going to come in later. So keep that in mind. All right, let's go to the horizontal asymptote. Where is the horizontal asymptote?
Y equals 0.
That is correct.
Is there another one?
Nope, that's it.
So it could be anywhere between the
Anywhere on the graph. Do you see how this arrow will get closer and closer and never touch? This arrow is going to get closer and closer and never touch. Right? Asymptotes means it gets closer and closer, but it never touches it. Never touches an asymptote. All right, now, holes, none. No holes. Do you see any holes? It would look, it'd be like you have an open circle. I don't see any. I mean, I do. It's right there, but that's because I drew it. Okay, now, when I write my function, this is where it's going to get really challenging, so I hope you're listening. The first thing I want to do is I want to write what's in the numerator. Exactly, the numerator! Get to the numerator! What do I put in the numerator? Like, what thing am I putting in there? No, like, what word? What word?
Minus 0 and x plus
Natalie is right. The x-intercept.
numerator.
That's what we're putting in the numerator. So when I look at 3, 0, I always want to think opposite when I write this as a root. So I see 3, 0, so I'm writing x minus 3. And what am I writing for x for -2, 0?
X plus 2.
Very good. Now, be careful. Here's another opportunity for you to make a mistake. Look at these x-intercepts. Is there anything interesting happening at those x-intercepts? The answer is no. What I mean is, does it touch it and come back from the same side?
I don't get it.
No.
Okay, give me a second. Everyone's so angry. Like if it looked like this, like if it looked like this, do you see how it touches and comes back?
Yeah.
Do you remember what that kind of root is called?
One square. Double.
A double square, double root is what it's called. So when I write down whatever, let's say this is 4. When I write down x minus 4, it needs to be x minus 4 squared. Will that happen today? Yes.
Oh my God.
Now what if it looked like this? One more and then we'll take yours. What if it had looked like this?
Oh, triple.
Remember, that's the triple root. So when you write that one, it would be cubed. That's coming back into play. Let's go. Because if it goes and touches it and comes back the same direction, it doesn't have to go up. It could have gone here and come back down. As long as it doesn't cross, it touches but comes back, that's double. All right, when it looks like that, like here, I'm going to go Dino, then Diana, or so Dino, Pablo, Diana. It looks like that, that's cubed. Dino?
Okay, so how did you get the vertical asymptote?
The vertical asymptote, I looked at where is it never getting to. And it's never getting to right here. And it's never getting to right there. Like if I look at my graph. Let's go Pablo next.
If,
Well, then it's going to be really difficult for me to answer.
okay. Okay, now.
Let's go Diana, and if it comes back, we'll go to Benji.
Okay, so would the denominator be a double because it's going like this?
Well, so now we're going into the next thing, right? So the next thing is we need denominators. All right? Where do I get denominators from?
From your y-intercept.
No, not the y-intercept. Where do I get? Very good, Shyla. You get them from the vertical asymptotes. And I see x equals -1 and x equals 2. So writing those would be x plus 1 and x minus 2. Now, I told you this is an opportunity to make a mistake. If you look at x equals -1, do you see how 1 is going up and 1 is going down? The blue, right? Going up, going down? That's fine. Leave it alone. Leave it alone. It's to the first power. Do you see how at this asymptote, these are going in the same direction? That means on x minus 2, it's going to be squared.
But I thought it was squared because what?
You thought it was squared because what?
Double?
These are not roots, right? I'm not talking about roots anymore. I'm talking about asymptotes. They're different things.
So,
Diana, it's the first time. It's okay if you're not understanding. Okay, that's why we have today, tomorrow, Thursday, and then Friday.
wait, is there ever going to be cubes?
Yes, there could be cubed, but not today.
Cubes, though.
Not today.
We're not there yet.
We'll get there. We'll get there. We'll get there. I like the curiosity. Can I explain why it's squared?
Yeah.
Okay, I'm going to explain it again. Diana, here's another chance. I'm explaining it again, but she asked for it again. So, when I look at my asymptotes, hopefully you've drawn them on your graph. Look at your asymptotes. If you see that the function is going in opposite directions near the asymptote, then it's to the first power. Leave it alone. Opposite. That blue arrow is going up, blue arrow is going down. Okay? If you see near your asymptote that the arrows are going in the same direction, they get squared. So that's why x minus 2 is squared. Yes, so that's why x minus 2 became squared. Because it's x equals 2, when I make it in the function, I've got to think opposite. Because that asymptote is from here. The x equals 2 asymptote is from this. Diana.
Okay, there's a parabola there. That's why I squared it.
That is part of it, but it's also because it's going, this is also going with that one.
Okay, if that wasn't existent,
It
would
will.
still be squared.
It will exist.
Okay, but if it was,
You can't just take it away. All right, so now put a big A in front. Put a large A in front. We need to find the coefficients. All right? Now, we haven't used one thing that we found on the previous slide. We don't have any holes, so we can't use that. there's one thing we haven't used.
Horizontal. Why? Wow.
The horizontal asymptote you can see is x times x is x squared. X times x squared is x cubed, so that's why it's y equals 0. There's the other thing. The y-intercept. All right, so I'm going to plug in 0 for x. Okay, times a. And what was the y-intercept? Was it -3? -2? I don't know. Let's see. It was -2. All right, let's do a little bit of math. What's 0 minus 3?
-3.
0 plus 2. Multiply, you get -6 over 0 plus 1. 0 minus 2. Square -2. 4 times 1 is 4, equal to -2. How would I move that -6/4 to the other side? Times? No. No, 4 over 6. That's called the reciprocal.
Oh my God.
Multiply by the reciprocal. Okay, so we have A equals, what's -4 times -2?
+8.
Very good, so 8/6. Let's reduce it.
4/3.
4 over 3. So when I write my answer, I'm going to write f of x equals 4 times x plus, I guess I did x minus 3 first, didn't I? X minus 3 times x plus 2 over 3 times, and then don't forget the x minus 2 needs to be squared.
How do you know it had a coefficient?
Well, I found the coefficients. That's what A was. A was 4/3.
Do all of them have this?
Yes, you need to find A. All right, let's go ahead and pause this.
I have a question.
Yeah, first, yeah.